Hello everyone, you are welcome to this class. So in this class, we want to look at another topic, and that is angles of elevation and depression. So we looked at some other aspects. We looked at bearing uh, before. We've looked at trigonometric ratios. So this topic will be application to trigonometric ratios. So that is the reason why, if you have not watched trigonometric ratios, so you have to watch it before you watch this one so that you understand where we are coming from. So we have the following objectives. Uh, and what are the objectives for this class? So by the end of this lesson, you should be able to identify angles of elevation and depression. Not only that, you should be able to, but also to be able to measure angles of elevation and depression of a point or an object. Then you should be able to sketch diagrams for angles of elevation and depression. So that is for this level. So we're going to look at the next one now. So the next one is what is angles, or what are angles of elevation? Angles of elevation. So when if we are standing, and you try to look, uh, let's say for instance, from what we have here, So let assuming this is a boy standing here, all right. This is a boy standing here. When the boy is looking straight, so that is the essence of this horizontal line. So, but if the boy wanted to look at an object at the top of a building, so the boy will have to raise his head up. So the difference, between when the boy is looking straight, that is the horizontal level, and the line of sight to sight the object is what referred to as what? Angles of what? Elevation. So that's why we have this angle here is called the angle of what? Elevation. So that's why I said there that when we raise our eyes to look up at an object, to look up, you raise your eye. So the amount of turn you made to look at that object, so is what we call, so the angle between the line of sight and the horizontal line is called the angle of what? Elevation. So that is what we have here. That is that angle. So the angle of elevation of the object from the observer is what? Is the alpha degree that we have there. I hope this is very clear. So if that is the case, let's now look at what is angle of depression. So angle of elevation, we have learned it now. So that is the angle you are going to form from when you are looking straight and when you want to look at an object above you. So you are downstairs, you want to look at somebody at the top of the building or in the fourth floor, and you're in the ground floor. So the amount of turn you made to look at that person is what we call angle of what? Elevation. But angle of depression is the opposite of angle of elevation. So when you are at the top of a building, so we have someone here, so this is someone, this is a man here, it's at the top of a building, and you want to look at somebody or object at the ground floor. You are on the fourth floor, you want to look at somebody at the ground floor. So the angle you are going to turn, you are going to depress, from the word depress. So you depress your eyes, that is, you lower your head. So the amount of angle or the amount of turn you are going to make to look at that object or the person below you is what refers to as what? Angle of what? Depression. That is, you are depressing. Elevation, you are elevating, you are raising your head up. I hope this is very clear. So that is what refers to as angles of elevation and what? Depression. So let's now look at the relationship we have between angle of elevation and depression. So if you look at this man now here, so this man, by the time he's looking at the object above him, that we have here, this object here, so the man will have to raise the head up to form angle of elevation. But if the man wants to look at something below, for example, you are at the top of a building, you want to look at the helicopter going, so you have to raise your head. So the amount of turn you made to look at the helicopter that is above you is angle of elevation. And the amount of turn you made to look at someone at the ground floor is what refers to as angle of what? Depression. Because you have to depress your eyes. And when you want to look at the helicopter, you have to also raise your head, you elevate your head up. So that is the difference we have between them. So that is the reason why we have, you look at it now. So this horizontal line here, this horizontal line that we have above here, and the horizontal line we have here. So depression is the alternate of what? Elevation. That is, angle of depression is equal to angle of what? Elevation. So it is going to form alternate angle, which is going to give us Z, as you can see from the diagram here. So this is how to get this one, because there are sometimes, by the time we start solving questions now, you see, understand what I'm trying to look, or what we are looking for. So let's now look at instruments. The instrument they use, we use to measure angle of elevation and depression is what we call theodolite. So surveyors, they use this a lot. You must have seen this before. You must have seen this object before. I've seen some people, they will be at the roadside using this instrument. So the instrument is what we call theodolite. They use it to what? To measure angle of elevation and depression and some other things. So this is instrument of surveyors. So, but we have a simpler instrument that we can also use, that we have mathematicians use as well to measure angle of elevation and depression. That is clinometer. So we have, you can use this. So it is, you just use this aspect here. It is this aspect that you're going to use to sight this place, to sight the angle you want to measure, the object you want to look at. So as you are, if you are raising it up, this thing will be going up like this, and this line will be changing. So wherever it stops, we give you the angle. And if you are looking down, the same thing, it will be going this way. This line, this object will be going this way, and that's how you can see that we have 0 to 90, 0 to 90. So it depends if you are looking down, if you are looking up, that's what you use it for. So we're still going to look at the practical aspect of that later on. So, and I think that is that on this. So the next is now to look at examples and see how we can solve problems on this. So that is what we're looking at now. So the next example that we have here. So in solving examples on the angle of elevation and depression, so there is a need for us, for you to sketch the diagram. So if you fail to sketch the diagram, you not get a full mark. It's one of the things you need to understand. And without sketching, you can't get your answer correctly. So what we're going to have now is, let's look at the question. So from a point on a level ground, 40 meters away from the foot of the school building, So let's assume that the school building is here. We have a school building here. This is a building. So it's a very big building. So a student, the point, this is the level ground, this is the level ground of the building. And there's a point on the level ground that is 40 meters away from the foot of the building. Are you with me? So a student that is standing at that point observed that the angle of elevation of the top, that is, the student is about to look at the top of the building here. So the angle of elevation that we're going to have there, so that is, you look at this line of sight. So the angle of elevation will be here, which is what? 57 degrees. Are you with me now? So the question now is that calculate the height of the building. So we are going to calculate the height of this building, which is X here. So if you draw it properly without putting the building, this is what you're going to have. You're going to have this. This is a right angle. So this is X, the height of the building. Let's say it's H. And this is 57 degrees. And this is 40 meters. Now, from here, we are looking for H. So the first thing you can see, we have interpreted it to be a right angle triangle. And from here, we can label everything. So this is hypotenuse, this is opposite, and this is what? Adjacent. So we now ask, since what we are looking for is opposite, and we are given adjacent, so what are we going to do? So we are going to make use of O and A, that is so. So which means that we are using TOA. Don't forget what we use. So if you have not mastered trigonometric ratios, so you have to go back. This would then be what? Using what? TOA. So which is what? Tan theta equals to opposite over adjacent. Opposite over adjacent. So, and the theta here is 57. That will be tan 57 degrees equals to the opposite here is h. That is what we're looking for, divided by the adjacent, which is what, 40. So we can divide this, right? All right. So what we're going to have next is what is tan. So we can cross multiply. That's going to be height equals to 40 multiplied by what? Tan 57 degrees. So we now find tan 57 degree. 57 tan, that's 1.5399. So 1.5399. 1.5399. So when you use calculator of this, so we multiply this together. So that's going to give us 40 times 1.5399. So that gives us 61.6. So 61.6 meters. So that means the height of the building. So we can then say that the height of the building, the height of the building is what? Is 62 meters, approximately 62 meters. I hope this is very clear. So that is that on this. So example one, don't forget what I said. You can pause and look at it again, pause and go back to it again. So for you to master it, right? So that is that on this one. So the next one is the next example is example 2. So this one is on angle of depression. The same thing you have to sketch before you can solve this. So the angle of depression of a buoy from the top of a building. So we have a building. So when you have a building, so let me use this side. You have a building. This is a building. And a buoy is at the top of the building. All right? So the angle of depression of a buoy from the top of a building is 62 degrees. If the height of the building is 8.7, find the distance between the building and the buoy. So from the top of the building, that is, someone is at the top of the building looking at the buoy. So the buoy is here. This is the buoy. From the top of the building, when you are looking straight, the angle of depression of the buoy, so this is angle of depression, is 62 degrees. The height of the building is 8.7 meters. All right? Then find the distance between the building and the buoy. So this is the buoy and the building. We are looking for the distance between them, which is what? X. Let's say it's X. So sketching this out, I told you here that look at what we have here. So if angle of depression is this, then the opposite of it is angle of elevation. So in that case, so that is the reason why this will then be equal to 62 degrees. So this is going to be 62 degrees. I hope I'm making sense. So if you bring out the diagram, this is what we're going to have now. We're going to have it 62 degrees. This is a right angle triangle. This is 8.7. And this is what we are looking for. So from here, we can label the size now. So this is opposite, hypotenuse, adjacent. And you can see it's TOA, that you are still using TOA. So using TOA now. Using TOA. So which is tan theta. Tan theta equals to opposite over adjacent. So which is tan 62 degrees equals to the opposite, which is what, 8.7 divided by what, X. So from here, this is over 1 now. When you cross multiply, that will be X, and divide this into 2. X tan 62 equals to what, 8.7. So which means X equals to 8.7 divided by what, tan 62 degrees. So that's what we're going to look for now. X equals to 8.7 divided by tan 62 degrees. So 62 tan So that is 1.8801. So that's going to be 1.8801, 1.8801. I hope this is clear. 1.8807, sorry, 8807. So we now divide this. That's going to be 8.7 divided by 1.8807. And that gives us x equals to 4.6. So therefore, x is equal to what? 4.6. So which means that the distance between the boy and the building is what? 4.6 meters. I hope this is very clear to you. So that is that on the angles of elevation and depression. I hope you find this video useful and helpful. Don't forget, if you are new to this channel, to subscribe and make sure you turn on your notification bell so that anytime I release video like this, you'll be the first person to have access to it and benefit from it. And not also, if you are watching this video, try to watch it as many times as possible to get the whole gist of the concept treated in this video. So we're going to meet in our next video. Bye for now.